Hello, everybody. This is going to be a quick demo on how to make sense of the tools you have at your disposal for solving the final boss of assignment 6, the max path length portion. And so really quickly, let's run our test suite and run it as a JUnit test. You can see that I'm passing all of the exponent, array sum, and dragon portions. I'm passing some of these, the comprehensive test. I pass all of the preliminary tests. Let's go ahead and look at what the preliminary test is testing, so we can sort of make sense of it. First of all, the chart that is defined right here with these Booleans looks a little bit like this. It's a whole bunch of empty spaces with one stone in the middle, and we're going to start at that index 1, 1 right here. This is going to be a very simple test. Before it goes to call your max path length, it's going to copy the array. It does this so that it can tell if you've changed it when you go in. So we copy it, we pass in that copy, it comes back with an answer. We're expecting that to be 1 because there's a single stone there. But before we check to see if the answer is right, we check to make sure that if the chart is not restored to its original state. And normally we try to avoid mutating our data whenever possible. Mutating, by mutating, I mean changing it. In this algorithm, it's perfectly fine to mutate the data. That's how I did it. And it's a perfectly valid algorithm to build it that way. It's critical that you return it back to its original state, not just to be polite, but for it to work on all of the cases. If you don't restore it back to its original state, it'll fail. And so it's not just to be polite. It would pass under these circumstances, but it's best to know now that you need to restore it back to its original state with this simple case. So that's why I put it in there. So I actually passed that. The algorithm that I've built here, I've built a somewhat contrived one that fails under some circumstances so that we can show this off. But we passed that. We passed, look, lone chasm, lone stone. That's going to be a 1 by 1 matrix of Booleans. This is a 1 by 1. This is 2 by 2. We can sort of see these things are empty, right? We get down here to sword north, and that's failing, even though all the 2 stone ones seems to have worked. Sword north and east fail, but sword south works and sword west doesn't. So that might be a clue as to what I did to break this thing. And see, in another case, I have a situation where I have an array index out of bounds, -1 is working there. And so you can start to sort of see, maybe from this, you can discern what went wrong, what went right, and that'll help you debug it. That is somewhat good. Hopefully the following max length debug app that we built will help you even more. So I'm going to run this as a Java application, and it brings up this screen, which has the exact same test cases from the comprehensive one, except you can see what's going on. So again, this is the lone chasm. It's a single cell of a chart, and there's no stone there. And so it's perfectly fine to try it out. It should return 0. That's what the solution that we've done is. It passes the lone stone one, the 1 by 2. You can sort of see what's going on. And this is easy for me to read, right, because I built this. But if you're confused about what all these green and gray tiles mean, and oh my goodness, there's going to be some yellow ones here in a second. Over here in the top right, there's an info key, and you can see what each of these things mean. So the student information, we don't have as much information because we only call max path length, and it just tells you what the final answer is. So there's sort of a start stone, which will have an answer. It'll have this little thing that indicates that it starts there. There are other stones in the world. These are chasms. This 0 could be the start chasm. It would always return 0, hopefully. And these are chasms that aren't the starting one. Over here on the right, we have the instructor version, which I built something that gives out more information. It tells you everything along the lines of the way in which I built max path would return. It obviously will return 0 from all these things on the edge. These guys are not on the path, so that's a stone on some other path from this starting location. You can have an unreached stone where there's going to be one down here. It's like an unfound island, where you could actually have it where There was something, let me find it here. Yeah, so this is one where you start here and it never finds that. So it's possible for there to be an unfound island. There's no problem with that. You would never discover that, but that would still be there. So that is what the key is. Let's talk about how we can use this to figure out what's going wrong. So again, we see that these things are all reporting correct. We have 21 out of 30 are correct. If you want, you can click this button and uncheck it. And now it just narrows it down to just those that are not working. Sometimes it's nice to be able to see the ones that are working, because sometimes that information is valid. I mean, it's interesting that all of these swords work. I mean, excuse me, the south one works and these other ones don't. So that might help you debug it a little bit. One last thing I wanted to show you is that for a couple of these, they're not just returning the wrong result, right? Like this guy returns the wrong result. I was expecting 10, it returned 7. So you can sort of look at this and say, oh, like instead of returning this full 10, it returned these 1, 2, 3, 4, 5, 6, 7. Maybe that's what happened. In this case, we actually threw an exception. So you can see it's an array index out of bounds exception. I sort of forced this in, but it's not completely unheard of that that some of you will hit this problem. You can see that I asked for an index that was off the edge. So I asked sort of -1 on rows. And when I was expecting it between 0 and 5. And so you can look at this. Sometimes this, seeing the stack trace will help. A lot of times, I'm not going to lie to you, it would be easier to sort of figure out that one from this stack trace, because you could click on this line. Now, if I clicked on this line right here, it would take you to my solution for this problem. Although broken, we wouldn't want to rob anybody or deprive of anyone of the joy of solving it yourself. So I won't click on that, but the exceptions, you might want to come back over here and sort of tunnel, and it'll show you exactly the line that has this array index out of bounds exception. So with that, hopefully this will help. Good luck. If you run into any trouble, reach out to us on the helplines and we'll be here to help.